And this is the last of the lightning talks in this session. We're going to have Kate Sugrue, who spoke with us last year when she was working as lead data science at VHI. She has since joined Deloitte as Director of AI and Data, where she focuses on helping organizations implement AI solutions at scale and to navigate the complexities of sustainable AI implementation. A champion of responsible, ethical AI, Kate is committed to ensuring that AI systems are fair, transparent, and built with integrity. And in her talk today, she's going to tell us about bias and underrepresentation. So please welcome Kate.
Thanks, Elaine. I'm here already because I only have 12 minutes and I want to make every second count. Thank you so much for having me today. Those talks are really, really interesting, so tough acts to follow. Right. So I have 12 minutes. This is the only interactive part, so please interact with me quickly. Yep. What does this number represent? Can somebody tell me? Anyone, what do you think this is?
We need that around 500 to
Yes, yeah. Thank you. It's a really important statistic because it's so low. And it's not just a statistic. It's not just something that's infuriating. It's something that's built into the code of bias in the future, okay? And this is something that impacts every single one of us, not just that we're predominantly women. Well done to the men for coming along. This is something we should all care about. And before I talk about why we need to care about it, let's talk a little bit about what bias is and where it comes from. So there's three types of bias, right? So it comes from the data. So if we have skewed data, if your data isn't representing reality, you're going to have skewed AI, okay? So it's the same with old adage, garbage in, garbage out. It's the same thing for AI as it is for any data analytics. The next thing that happens is, I don't have a pointer, do I? Okay, so algorithmic bias comes from, it stems from data bias, essentially. It's when our algorithm in the AI perpetuates a bias that's in the underlying data. So if the data is bad, the algorithm on top of it is going to keep learning from it because AI is all about training and algorithmic learning. So you're teaching it bad habits, essentially. And then human bias comes from us. It comes from not having enough diverse views at the table when it comes to your data science team. So we can either consciously or subconsciously encode our bias into our model and into our data and our feature selection. So why does it matter? Like, why do we want representative data? It's not just a nice to have. It's in this little pink box here that I wish I'd put at the top of the page now that I think of it. It's trustworthy AI. If you've got biased data, you can't have trust in your AI. So bias and representation are the founders, are like they're bedrocks to trustworthy AI. So if you have diverse data, it improves your AI reliability across all groups, not just some. If you have your inclusive, like having inclusive data sets ensures that your AI is going to be fair and it's going to stop us from perpetuating discrimination that's in our underlying data. And also then, I'll talk about this a little bit more, but diverse teams really drive unbiased data, and they really help to mitigate the risk of having underrepresentation. So why do we need to address bias? It's not just that it's the ethical imperative. We all should be doing this. It's the decent thing to do from a sustainable point of view. We should be having representative and unbiased data, but it's also good business sense. We need to have unbiased data because we've all heard of the horror stories out there when companies release something and it's proven that it's an unbiased data set that's come out with like really bad results for that company. Like, it's bad for the company and it damages their brand reputation and that damages their market share. But also we have to, like, it's not just a nice to have. There's regulations around this, there's legislations around GDPR and the EU AI Act. Okay, so I want to talk us through just two case studies that, if you're anything like me, they'll really, really annoy you. So the first one here is the Goldman Sachs one. So this is in 2019. This was Apple Card. So basically what happened here was they didn't check their data for bias. There was algorithmic bias that built upon really, really poor quality data. So they looked at earnings from really far too far back. They didn't take into account things like maternity leaves. They didn't take into account parental leaves, anything like this. They treated apples and oranges like apples and apples. Like, they did not stop to think, how is the women's earning history a little bit differently? So what actually came about here was that we found that there were households where the households were jointly assessed. The women actually had higher credit scores, but her lovely husband got credit card approval 20 times higher. Like, that just makes my blood boil, and it should make everyone's here blood boil. So that was one of the really landmark cases, and it was a really high profile one. And I think that this is one of the ones that really brought the importance of bias and representation to the forefront. So the next one is actually worse, because it has, it's like, there was far worse impact of this one. So this was a really high-tech AI that was designed to help radiographers detect cancerous tissues. The problem was that it was only built on white tissue. So when they took all the mammograms, they based the scans were all from white women. There wasn't enough ethnicities brought into it. So what actually ended up happening here is that Black women were underrepresented in the data, and the tissue formation was different, and the model wasn't able to detect cancerous tumors in Black breast mammograms as Black mammograms as well as it was for white mammograms. So what happened here was these women had cancer. There was a delay in the diagnosis, and it led to mortality, like increased mortality rates for Black women. So that's the doom and gloom part of the morning. I'm going to bring it up a little bit now. We're going to talk about some amazing women. So 5 of my heroes here on screen. Ada Lovelace, can't talk about pioneering women without talking about Ada. So she's why we have programming. Grace Hopper, she invented the first compiler, and so she changed how we can program, and she made it like more mainstream. She brought it to us all. Fifi is really like, these 3 ladies at the end are still alive, and they're really worth following. So she created ImageNet, and this is a massive data set, and it just basically revolutionized deep learning. And she's credited with enabling the current AI boom. So she's a phenomenal woman. Please follow Joy. Not only is she like a founder of the superhero league that I want to be in, the Algorithmic Justice League, she actually feeds into a lot of research, and she herself identified facial biases and facial recognition software. So she's phenomenal. And then Timnit is just fantastic. Like, if you follow her on LinkedIn, she's just really got inspirational AI ethics. So she's definitely worth a follow. So this is to inspire you. I've put these up here to show you these women, because I want to think about next, like, this is what these ladies are doing, but what can we do as data scientists? So how we can empower change is by increasing our AI literacy and being aware of what we need to do in order to ensure that we are being as unbiased and making sure that women are representative. So the human in the loop is the first thing. We need to make sure that we have accountability. We need to make sure that we are always the decision makers. Computer in the loop is fine for things where it doesn't matter. Like, if you want to make an AI that's going to design paint colors for your room, you don't need a human in the loop for that. Like, that's a computer in the loop application. But just assess your use cases and make sure that you're putting a human in the loop where it needs to be there. Your hidden biases are really important, right? So we might take out a feature when we're doing some model selection, but we have to think about what's a hidden bias. So if, say, we don't want to have gender as a feature for something, for credit card scoring, we take out gender, but then there are other things that can infer our gender. So, like, if you looked at my shopping history, if they looked at my bank statements, my shopping history is very different to my husband's. You're able to infer my gender. If you look at my employment history, you'll see maternity leaves in there. You're not going to see him taken off that time. Like, you're able to infer gender. So you have to always look at the uncovered hidden biases, and just keep digging deeper and deeper to ensure that there's no way of inferring that feature once you've taken that feature out of your model. And then also recognize that AI isn't perfect. There are limitations, and make sure that we are always putting our own ethical decision making at the forefront of what we're doing. So that's kind of what we're doing and how we do it, like why we have to do it. But I want to talk a little bit about how we actually measure bias. So demographic parity, equalized odds, and model calibration, right? Equalized odds and demographic parity, they work best hand in hand. Demographic parity just means that, say if you wanted to hire 10 people, or say if you wanted to hire, if you're hiring people and you have to say, right, well, I want to hire 10% of men and 10% have to be women. Now, that's not always the case that the 10% of men or the 10% of women are equally qualified for that role. So it's kind of on its own, I don't feel it's important enough to use. Whereas equalized odds is about making sure that there's true positive and equal true positive and false positive rates. So basically, this one's kind of known as the fairness one. And then model calibration is ensuring that your outputs, your outcomes are equal across your cohort if you take your feature out. Okay, so. This is how we do it. So in pre-processing, so we can ensure our data is unbiased, right? So we resample our data. If we're taking gender as a feature here, if we don't have enough women to be equal to our men in our cohort, we keep sampling and sampling and sampling the women only, so that the women are represented more in our sample data set. And then we apply a greater weight, okay? So we can say, right, treat the women more importantly in this sample, okay? And then the next thing we can do is that, like I was talking about there, we identify and we suppress features that are correlated with those protected attributes. It might not be the attribute itself, it's correlated with it. Then in the processing side of it, right, we have fairness constraints. And that is simply just a really strict instruction that you're giving to the AI. You're saying, cop on, treat the women as the same as you treat the men. And you can actually do that if you can code that into it. Adversarial debiasing is, I think of these as it's a second model that works in tandem alongside your model. And I think of it as a whistleblower model. Okay, so it's going to be like a telltale, essentially. So it tells you when the model is doing something it shouldn't be doing. And then regularization terms, these really work for me in my work. So LLMs, models are people pleasers, and these are penalties that you apply. So when you penalize them, they're really super sorry. And they do what they're told the next time. Like, it really, really works. So I would definitely try these out. Okay, this is then in the post-processing. So then we review it and we see how has it worked, okay? And we have to go backwards then and say, oh, is there anything I need to do differently? So we can adjust our decision boundaries and we think about it and we say, like, is that what I was expecting it to do? Would I change this somehow? And then we can recalibrate. So we fine tune it. So it's not just a matter of doing it and then deploying it. It's always about assessing it after the fact. So we can recalibrate our fairness metrics, and then we can make targeted adjustments for the actual group specific ones. Then in terms of like the verification of it, so having a fairness audit really, really helps. So like after you've done the work, making sure you have a team that's out there to do a fairness assessment of it, having model cards to understand and increased transparency, and then like making somebody accountable. So having clear ownership of it, okay? So that's just like the broader, I want to look at it from a broader framework point of view. So the really important thing to say is that we need to build diverse teams. The world isn't homogeneous, data isn't homogeneous. Why do we have so many homogeneous teams? The one that jumps out of my mind all the time here is Grok. If there were more men sitting, if there were enough men around that table, if there were more women around that table, would we have seen a model being produced that was creating images of naked women? I don't think so. There needs to be representation, there needs to be more women at the table, and there needs to be every ethnicity covered. There needs to be an ethical review board in companies to evaluate AI projects. We can't just run ahead and assume that everything's going to be fine and nobody's correcting our homework. There needs to be somebody there to keep us all accountable. And we need to ensure the full transparency with the model cards, like I was saying. And then we also need to make sure from a business point of view that we're keeping compliant with GDPR and the EU AI Act for if you're working in Ireland or Europe. This is a quick cheat sheet in how to actually try to make sure you're being fair and unbiased at all times. So first thing we're doing is you define and you identify your protected attributes. We're talking about gender this morning, so that'll be it. Then you segment your data by that protected attribute, and you compare the performance across both of those genders. You evaluate the accuracy for each of the subgroup independently. Where they're different, you come back around and you calculate the fairness metrics. Okay, and then you put in your mitigation techniques. So you might need to go back in and resample again, or you go back in and you adjust or you reweigh it to say, no, pay more attention here. And then you go back up here to step 2, and you keep going step 2, 3, 4, 5 until it's all clear. And when you're finally happy with the performance of your model, you go down and you document it so that people can learn from you in the next stage. Okay, this is the fun part that everyone loves talking about, governance, who doesn't? So these are just ones that you need to be mindful of. So your GDPR and your EU AI Act are really, really important. So like I was saying, it's not a nice to have. It's actually, we have a requirement here. And I'm going to leave you with this then. So what I would say is we all have a responsibility to be a woman in the loop in this, and we can directly influence AI. Like, we have a lot of power in being data scientists. We have a lot of power. So what I would say is that we need to champion initiatives. We need to be hiring more women. We need to be promoting women, not just when it comes to the actual workforce. We need to be mentoring young women in STEM, and we need to be encouraging women to come into this profession, because we need more female bodies at the tables. It's essential, like it really is. And there's a lot of organizations out there. I don't know if I was allowed to link them in here, but there's a lot of organizations out there that are actually collecting data on ethical and biased that we observe in our workplaces. So if you want to talk to me afterwards, I can give you those organizations, and it's really important to feed into those also. So thank you for having me. I think
Thank you, Kate, and thank you to all of this morning's speakers. Remember, you can give them your questions in their Q&A session that's going to be after the interactive lab. But before the interactive lab, which is coming up next, we're going to have a very short break.